Alright, we are back. We are back. These streams are... We're still testing things out here at Dubious Studios here. Back. Oh, there we go. We're back. Monitoring myself. Streams are... Okay. Alright. So we're here. It's April 29th. I need cool intros and stuff. Well, we'll get there. This is day 2. And kind of just winging it. Let's go back to the music. Hold on, let's play some music. Had some ambient music yesterday. And let's just continue with it. You guys can't see it right now, but hold on. Anyway, y'all don't need to see. We're going to try different screen setup. We're going to try like this. We're going to try it like this. And, yeah. Let's just jump into it. It's 9 o'clock. I don't want these streams running too late. It's 9 o'clock Eastern time. Hopefully this music isn't too loud. Hold on. Let's monitor. Let's just turn it down just a little bit more. Okay. We're back. We're still on the computer science thingy. I don't even know. I guess I never explained. Well, I guess I can explain now. I'm learning computer science. You know what? I'm going to do something. Hold on. Let's change to this. There we go. All right. Yes, I'm learning computer science. I went to school for it, but school kind of sucks, so I'm teaching myself computer science just for funsies. I want to make stuff. That's my goal. I want to make things. I want to build softwares. I want to work with embedded systems, and I think this is necessary. So I've been learning from Code Academy for it's going to be almost 2 years. If I started in 2024. Yeah. It's a lot of content I've been going through, but yeah, I didn't realize it would take this long. I thought it would take 3 to 6 months, and I was on this treadmill where I'm like, I can do it in 3 to 6 months. What? No, never gaining a realistic understanding of how long it would take. Yeah. So, well, I think I'm getting close to the end. I'm on learning about databases. I'm done with all the Python coding. Good Lord. I kind of dislike Python, but that's a story for a different day. Alright, that's enough yapping about me. Maybe the beginning of these streams will just be me yapping, and then we'll get into the work. Let's do the, yeah, I like this. Now y'all can see with me. Can you see this too? Let's see. You can. Alright. So we're picking up where we left off from yesterday. Yesterday we started with no SQL. And I was looking at this on my lunch break at work today, so that's why I have a little bit of notes. And not that anyone is paying attention, I bet. Anyway. Alright. NoSQL. Let's just do a recap because I was learning already and now I need a refresher. So NoSQL means not only SQL or non-relational. Any database that stores data differently from relational databases. Hold on, let's see what I have. Databases, okay. Databases, whatever. Arriving at NoSQL, the need to store and organize data, the need to store and organize the data records dates back to way before the term database was coined. It wasn't until around the 1960s that the first implementation of a computerized database came into existence. Alright, I'm just gonna vibe and not read out loud as much. Only the important parts, I think. Because I need to focus. Okay, so when datasets became exponentially larger and more complex, developers began to seek a flexible and more scalable database solution. And this is where NoSQL came in. Let's see what NoSQL's good at. Scalability. Okay. Designed with scalability as a priority. Flexibility, it's good at that too. Flexible. Doesn't require a schema. Can handle unstructured or semi. Hold on, can I zoom in a little bit? Okay, there we go. Now you can see my mistakes and up close. Semi-structured data in different formats. Can handle unstructured or semi-structured data in different formats. Developer experience. NoSQL requires less organization and thus lets developers focus more on using the data than on figuring out how to store it. Requires less organization. Let's developers focus on using the data and figuring out how to store it. Okay, this is not an exhaustive list, it says, but it's only some benefits. Alright. Let's organize it like this. Oh, they do have drawbacks. They are ACID compliant, ensuring high data integrity. NoSQL databases follow base principles and can often sacrifice integrity for increased data distribution availability. However, some NoSQL databases do offer ACID compliance. I don't know what that means. ACID compliant. Hold up, we can click it. Wikipedia page, here we go. In computer science, ACID, atomicity, consistency, isolation, durability is a set of properties of database transactions intended to guarantee data validity despite errors, power failures, and other mishaps. For example, a transfer of funds from one bank account to another involving multiple changes, such as debiting one account and crediting another, is a single transaction. Okay, I see what that's saying. So it's saying it guarantees that data is valid or gets transferred despite the errors or power failures and other mishaps that may occur. Atomicity. What is that word? Never heard of that word. Atomicity is the property of database transaction consisting of an indivisible and irreducible series of database operations such that either all occur or none occur. I'm still not 100% grasping that, but whatever. So all I need to know is ACID is a set of properties of database transactions intended to guarantee data validity. A little bit of a mouthful, but I think I understand the gist there. So relational databases are typically ACID compliant, ensuring high data integrity. Okay, that makes sense to me. NoSQL databases follow base principles and can often sacrifice integrity for increased data distribution and availability. All right. Disadvantages. disadvantages. NoSQL follows base principles. Often sacrificing integrity, data integrity. For increased data distribution. And availability. I'll just write a little note. As opposed to being ACID compliant, like relational databases. And then I'll write a little blurb on ACID. Compliancy. Let's see, so ACID compliant equals a set of properties I like that definition of Wikipedia, so I'm not gonna paraphrase it. I'll paraphrase it a little bit. A set of properties of database transactions intended to guarantee data validity. And then we'll do example transfer of funds from one bank account to another. I'm going to put data integrity in bold and ACID compliant in bold. Then the definition of ACID compliance. I'll put base principles in bold too. Put this in bold too. All right, let's keep moving. Some NoSQL databases offer ACID compliance. Ooh. Another disadvantage, no language standardization. SQL databases use SQL. Typically, each database uses its unique language. Okay, so now we're going to explore different types of NoSQL databases. 4 common types of NoSQL databases that store data in slightly different ways. In the examples below, we'll be using an e-commerce website to illustrate how each database may store the data. Okay. First up, we have key value. Let's put this in the notes. 4 common types. Of databases. So we have key value. Records organized via key value pairs. Oops, sorry. Oh wow, I didn't know I can get rid of those. Okay. Well, I knew that, but it just looks better now. Anyway. In this model, keys and values can be any type of data, ranging from numbers to complex objects. Keys and values can be any type of data. Keys must be unique. This is very reminiscent of the Python dictionaries, huh? Keys must be unique, so this is best when data is attributed no, this is best when that's a better way of wording that. Keys must be unique, like an ID number. Cool. DynamoDB and Redis are popular options for developers looking to work with key-value databases. Cool. Let's see what DynamoDB is. It's an Amazon thing. That's cool. Oh, excuse me. Oh. Amazon DB. No, DynamoDB. A Dynamo. A Dynamo. Popular options for developers. Pretty solid, pretty solid. All right, next we have document types, document based, also called document oriented database. Consists of data stored in hierarchical structures. Let's write that in. Document. Data stored in oh man, I don't know how to spell hierarchical. Nope, I tried. HIERKAR. Okay, I got that far. CHCHICICAL. Oh, I put HEI when it's supposed to be HIE. Okay. Oh, I didn't realize I made that mistake. I thought I made a mistake in this. Anyway, I'm getting too in the weeds. Data stored in structures, hierarchical structures. Supported document types. Oops. Equal JSON BSON. Oh, hello. BSON. Where'd it go? XML. YAML. Those are some names. Uh-oh. Did I oof? Oh no. I think I oofed. No, I'm back. Okay. I'm back. XML and YAML. YAML. Considered an extension of key value database. Is and provides querying not solely based on unique keys. Documents are considered very flexible. They can model relationships. This is what a document would look like. I want to take a screenshot of that. Command Shift 4. Here we go. Example, place in my document here, but it's no pun intended. Document example for my document. All right. MongoDB is a popular option if you're looking to work with a document database. Wow, there's so many different types of databases. Holy moly. Kind of need to speed up. All right, graph. graph. I graphed it. A graph database stores data using a graph structure. Okay. In a graph structure, data is stored in individual nodes called vertices and establish relationships via edges. The advantage of the relationship built using a graph database as opposed to a relational database is that they are much simpler to set up, manage, and query. In the graph above, we can see that there are 4 nodes. Neo is the username, hiking category, cameras is another category, hiking camera backpack is a product. Because the user Neo searched for hiking and cameras, there are edges connecting all 3 nodes. More edges are created after the search, linking a new node, hiking camera backpack. Oh, okay. Stores data using a graph structure. Sorry if the music got loud for a second on your end. Wait, let's test something out. If I mute it here, does it still play for you? Okay, it does. Alright, great. So you probably it didn't get loud for you, maybe. Alright. Data is stored in nodes, individual nodes. And establishes relationships via edges. AKA links or lines. Much easier to set up manage and query. kind of need to finish. Alright, we'll do... Hold on. Neo4j is a popular option for developers to work with a graph database. Okay, let's write that. Neo4j. Popular option. Okay. So next up is column oriented. Column oriented SQL, no SQL database, stores data similar to a relational database. However, storing data, instead of storing data as rows, it stores as columns. Column-oriented databases aim to provide faster read speeds by being able to quickly aggregate data for a specific column. For example, take a look at the following e-commerce database of products. Oh, so this would be a row-oriented. This is... I need to take a screenshot of that image. That's really good. Copy that. Image kind of just says it all. But let's write. Stores data similar to relational database, but instead of storing data as rows, it is stored as columns. Okay, I see. So instead of having... It looks like it just separates the ID. Well, it separates each of these columns in the row oriented and attaches it to a different column. That's what it looks like. Just looks like it splits it up. Aims to provide faster read speeds. Aims to provide faster read speeds by being able to aggregate data for a specific column. Oh. Example. Aggregating data and sales column doesn't pull adjacent data from rows like in relational model. It pulls data irrelevant to our query. Amazon's Redshift is a popular option for developers looking to work with a column-oriented database. Redshift equals popular database, column database. We've learned some of the fundamentals of NoSQL database technology. Let's take a moment to review what we learned. NoSQL stands for not only SQL, also called non-relational or non-SQL, and refers to any database that stores data in any format other than relational tables. NoSQL database technology grew in popularity due to datasets growing in size and complexity. NoSQL databases may provide flexibility, scalability, and speed advantages. NoSQL databases experience disadvantages such as lack of data integrity and lack of language standardization across different NoSQL databases. Common types of NoSQL databases include key value, document, graph, and column-oriented. Next time a project requires a database, consider the trade-offs between a relational and a NoSQL database and pick one that best suits your use case. Yippee, I did it. Yay. Oh, no confetti? Okay. Well, that's where I'll leave off. Oh, this is looking weird. Alright. That's where I'll leave off for today. Thanks for joining me. Maybe we'll continue tomorrow, maybe not. We'll see. I do have other hobbies. But I'm just trying to get this computer science thing done and over with, so I can move on to making stuff I want to make cool devices and software. Peace out. Bye-bye. Until next time.